Good evening. This is Carlton from the Pharmacy Seeds Network, March 5th, 2019. Well, I just thought I would go over a few more things here on the Raspberry Pi database charting system. I know most people aren't as intimately familiar with all of these charts, sensors, and what all the graphs actually mean. So I thought I would just go over a couple of things here. On the top here we have thermal mass in the two thermal banks. The lower green line is the main thermal bank on top of the stove. The blue line is the big 275-gallon tote. The red line is the combination of the two, and the line that you can't see down at the 0 right now because it's set to 0 because the sensors have been disabled. I won't go into all that right now, but the reserve water tank also acts as a like a passive thermal mass. Okay, so I guess I wanted to point out how this system works as far as the heat pumps and how the heat pumps and the venting system both are doing their part, and how you can see that reflected in the charts. I just realized today was an excellent example of that. We had some relatively cold weather today. It looks like we didn't get much over about 30 degrees. And last night into this morning we were down to around 8 degrees. I thought that's water temp. This is outside temp. Yeah, we were down to about 8 degrees this morning at just before 7 a.m. Before the sun came up. And so let's see, so last night I did quite a bit of stoking. I've been burning primarily ash and cherry in the greenhouse. This week is projected to be pretty cold, down into the single digits like this every night, so I'm running the thermal banks up pretty good. And you can see last night between like I don't know, around 9 o'clock or so and about 3:30 a.m. You can see those thermal mass banks climbing steadily in accordance with all the stoking that you see down here. The red line on this lower chart is the wood stove, and just for if you're looking at these charts and want to understand better, the key for these charts is down at the bottom. Anyway, so you can see I stoke through, and then this green line here is the upper and lower sensor in that thermal mass on top of the wood stove. And I have two different programs that I use to manage thermal mass and heat transfer. One I call Heat Dump 99, and that basically sets between 99 and 120 degrees for the thermal mass on top of the stove. Anything in addition to that, as long as the difference between that and the other tank is 20 degrees, between 30 and 20 degrees, it'll pump all that excess heat over to the secondary thermal bank. And so you can see the pot on top of the stove stay relatively steady throughout the night, and yet the total thermal mass level and the big thermal bank climb relatively steadily throughout that period. So you can see we're transferring that heat, and you can see where the pump kicks on and off at various points. You can see there's kind of a little bit of a tolerance shift there. But anyway, so I run Heat Dump 99 most of the night when I'm trying to accumulate mass amounts of heat in that big thermal bank. And then I have another program that I just rewrote this script for a couple of weeks ago, and it basically looks at the outside temperature and manages the thermal banks based on that. The temperature is 25 degrees or greater. It goes into super bank mode, which is basically the same as the Heat Dump 99 mode, and it pumps all the heat it's producing over into the secondary thermal bank. If the temperature is between 15 and 25, it goes to another mode where it lets that thermal mass on top of the stove, it keeps it between 130 and 140 degrees, so that gives a little bit more heat to dissipate into the greenhouse and to help keep the greenhouse temperature stable in those really cold nights. And then the third mode that it goes into is a super mode for anything below 15 degrees, and that basically keeps the temperature of that pot on top of the stove between 140 and 170 degrees. And so it basically keeps that thermal mass at a much hotter temperature, which is a greater difference in temperature between the air in the greenhouse and that thermal mass, and consequently it can dissipate more heat into the greenhouse and maintain stable temperatures that way. So eventually I'm probably going to set up some sort of a push button system so I can put it in heat dump mode, and then after a period of time it'll switch over to the automation mode. But I ran the heat dump mode all night last night until right here. Looks like about 3:23 a.m. and that's when I switched over to that new thermal control mode. And because the temperature was so cold, below 15 degrees at that point, below 17 degrees, well, anyway, either way, it goes mode 2 and 3. So anyway, it was low enough that that program managed the heat in the way that it basically kept all the heat in the pot and stopped transferring heat over to the second thermal bank. And you can see that reflected here in the chart, as you can see the larger thermal banks start to lose heat to the greenhouse. And then as the sun comes up here, you can see the average greenhouse temperature right here. As the sun comes up, you can see the greenhouse temperature start to rise, and there's still enough heat left in the stoves. You can see our last stove cycle's peak was just around 5:30, just a little before 5:30 a.m., and it was still producing heat up into sunrise here. So as the temperature in the greenhouse came up and the outside temperature came up, you can see where it hit the dump point, and it actually dumped all that heat from that thermal mass and transferred it into the big bank, which lowers the total relative difference between the thermal mass and the greenhouse temperature air. So that accomplishes two goals. That stores away all that excess heat that we had so it doesn't get wasted when vents open, and puts it into the big cube, and it also reduces how much heat we're producing in the greenhouse as the sun comes up and the temperature of the greenhouse starts to rise. And you can actually see the little venting cycles here in the greenhouse where these little dips are, where the vent was opening and closing to keep temperatures relatively stable in the greenhouse. So I just wanted to point out that the venting system kind of overlays with the thermal mass management system, and that we're managing this heat on a sort of a 24-hour basis, and then still trying to maintain our environment within a certain range. I hope this all makes sense to people. I'm just trying to help people better understand what's going on here. So anyway, so it dumps off all that excess heat back to the main thermal bank, and you can see that that main thermal bank and the stove, the pot on top of the stove, the smaller bank, stay relatively steady throughout the day because we had so much sun today. It was a clear, sunny day with good solar radiation, good heat from the sun, and you can see that reflected in the average greenhouse temperature too here. Let me see if I can find it. Yeah, see, we're up to 95 there, and we actually touched out around 99 today. And we didn't open the secondary vent because we're below 40 degrees on the outside temperature, so we're only opening the top vent and letting heat off the top. And so you can see how well that came through down into, we're getting sunset right around 6 o'clock now, and you can see it actually maintained the heat in the greenhouse above 75 degrees or so, maybe 72 in that range. Yeah, above 72 until I relit the stove around 5:15 or so. So anyway, I just thought this was a great illustration of how the thermal mass management works and how that overlays with the venting system, and how I'm managing heat on a larger scale, sort of managing it over a 24-hour period and trapping and saving heat when I can, and being as conservative as possible. Anyway, that's that. I just wanted to go over this. I thought my viewers might appreciate it, and might help people better understand what all these different programs and relays and pumps and vents and linear actuators and stuff are actually doing, and how well they're actually working. You can see all that data reflected right in the chart. And so as I go along here and I refine this, and I find more things that need to be kind of adjusted into a tighter tolerance, I'll continue to adjust that code, and we'll get this dialed right into nice precision environmental control. All right, that's all. Thanks for watching the Pharmacy Seeds Network. Hope you've enjoyed this. Don't forget to like and subscribe, and thanks for watching.